The use of the combined cohesive zone model and extended finite element method techniques for the patch shape performance analysis on the behavior of 2024 T3 aluminum structure reinforced with a composite patch, presented by Jabbar Safa Shahrazad. The objective of our work is to analyze by the finite element method the behavior and the damage of a 2024 T3 aluminum plate repaired by a simple composite patch of the carbon epoxy and an Adekit A-140 type adhesive using the extended finite element method technique for plate damage and the cohesive zone model for patch debonding. Adhesive Adekit A-140 was chosen because of its use in several areas. The interlayment and failure of the composite patch was not taken into account in this analysis. This is to promote only the separation between the plates, composite aluminum. The choice of the mesh is important in order to have the calculation of convergence with the results translated by the number of nodes and their arrangement, which characterize the element and its density in the mesh structure. The mesh elements used in this analysis are of type C3D8R, where the extended finite element method model is implemented, and also for the patch. For each structure, the number varied with the shape of the patch. The adhesive was modeled as an interface zero thickness with COHDD8 elements, where it is therefore necessary to introduce the rupture parameters. The experimental tensile tests concerning the 2024 T3 aluminum structure repaired and not repaired by the composite patch were validated by tensile curves resulting from the numerical analysis. For the validity of the numerical model through the study of the sensitivity of the mesh, through our study by the three-dimensional finite element method and by the use of extended finite element method and cohesive zone model techniques, we could analyze the damage of the structure repaired by the automatic propagation of the crack in the plate and the debonding of the adhesive. The validation of the curves of traction carried out on the structures repaired and not by composite patch became practical when one uses these two techniques while ensuring a good choice of the density and the types of elements of mesh. In our first analysis, we tried to see a comparison between the two shapes of the circular and square patch. In order to better transfer the damaged areas and to ensure less damage to the adhesive, we have tried to change the shape of the square patch parts as shown in the diagram. A second modification has been proposed, taking into account the triangular shape of the patch parts with a variation of the parameters A and B. The purpose of this modification is to minimize the stresses which are in contact with the edges of the plate. A three-square patch modification that touches the two edges of the composite patch that are parallel to the applied load. A four-square patch modification that touches the two edges of the composite patch that are perpendicular to the applied load. For our second part of the study, we tried to make the same modifications to the circular patch. In the first step, we tried to keep the width of the patch same as the width of the plate. On the other hand, we tried to minimize the height of the patch as shown in the figure. The second modification of the circular patch is to vary the width of the patch, while the height of the R1 patch increases similar to the structure repaired by the circular patch. If the width R2 decreases, R1 will have an elliptical shape which guarantees better structural strength and provides less material for the composite patch. The results clearly demonstrate that the shape of the edges of the patch has an impact on the reduction of the stresses in the adhesive and consequently on its detachment. The composite patch, whatever its size, ensures slow transfer and reduces the concentration of stresses in the damaged plate. The geometry of the edges of the patch is important in order to reduce the stress concentration at these edges. The square or circular patch automatically exhibits the same response in the strength of the damaged and repaired plate in terms of tensile strength. The modification of the height and width parameters of the patch, as well as the geometric shape of the parts of these edges, must be optimized in order to ensure a good quality of